um, or the power that move or travel with a great speed. Okay, but what exactly we want to do, and this is some funny pictures for uh, Rick. That was awesome. So knowledge is power, right? So you have heard power a lot, but in terms of physics, we want to see what the physicists and scientists thinks about the power. Okay. Okay. In physics, we define a power the rate at which work is done over a given period of time. How fast you producing the energy, that would be the power, right? Um, Mathematically, it is the work you do divided by the time. Okay. So the unit for the power is watt. And work, the unit of that you already know is joule, and the time is second. If you ask you, what does the watt means? You have heard kilowatt hour or kilowatt second. Someone asks you, what is the watt? What do you say? So I know this is watt, okay? And W is the work, which is joule per second, right? We would say that the energy per time or energy joule per second is what? And maybe I just put that in the what things because here it would be very confusing, right? What is joule per second? Okay, now the questions are not that hard. You just need to know how to use the equation. Uh, so calculate the power required by a car to accelerate from rest. So V initial is 0, V final is 25 meter per second, and the time is 5.5. Calculate the power, right? And the mass is 550 kilogram. You know the power is equal to uh, work divided by time. And what is the work done? You remember that the work done was changing kinetic energy. How do I know I use that? Because I have two velocities, right? Final and initial velocity. So I have to immediately think this is going to be changing kinetic energy, which is final kinetic energy minus initial kinetic energy, like half m v power 2 final minus half m v power 2 initial. So since my initial velocity is 0, this is gone and is just half mv final power 2. And here is time. I have everything to put in and calculate the power. Mass is 500 kilogram, right? V final is 25 meter per second. Everything is in a SI unit, and here is 5 seconds. So great. Just put that in a calculator. So 550 multiplied by 25 power 2 divided by 100. Okay, so it's going to be 3437.5. You can say that this is joule per second, or you can say that this is watt, right? Any question? Another example, calculate the power required to move 25 kilogram block. You have math from a driveway to the top of the house, which is 12-meter high. Total time is that. Again, power, you need power, right? Is work divided by time. What is the work done? Because you're moving something from Earth to some distance, and here is H. You already know work done is the same as change in potential energy. Is another things that you could think of. Here, change in potential energy is mgh final minus mgh initial, right? So initial height is 0, m GH final. I just put that here. Now put in the mass is 25, G 9.8, H is 12, time in 10.5. You just need to put in a calculator. 280 joule per second, or what? So it's another conversions that we could use. So 1 watt is 0.00134 horsepower. So horsepower is a bigger unit. It's like converting, if like I say 1 meter, okay? Maybe I just put it vice versa. Uh, 1 centimeter is 0.01 meter, right? It's like the meter is bigger conversion because this is small number here. So the same thing is horsepower. HP is horsepower, is much more bigger than unit than watt. Maybe when you're talking about a big power plant, maybe you want to use that. But usually when if, you want to read your bill, it's gonna be on watt, right? This is more common way of saying kilowatts, right? That is another kind of units. Um, Now converting 3500 watts into horsepower, what do you do? So I just write it down. I know I need a conversion ratio, right? What do you think? Should I put the watt down or should I put the watt up?
Down.
Very good. Why?
I don't know. That's what we did in chemistry.
Good. The thing is that I need to cancel watts, right? But that therefore I need to put it down. That's how you can cancel this and turn it into horsepower, right? Thank you, though. It's good that I see the student participate. So watt and watt cancel, and this is what we do. We do 0.00134. Oh, yeah. Okay. 4.69 horsepower. Now I want to convert 75 horsepower to watts. Now you know what to do. You need to put horsepower down because you want to cancel the horsepower, right? So 0.00134 horsepower, and on the top you put 1 watt. So this method you can use it everywhere, right? You have it. You need to know how to convert things using this method. 3.00134. It's now that's gonna be watts because the horsepower and horsepower cancel and just leave it watts. Okay. So these are the horsepower. When you have a light bulb, it produces 0.34 horsepower. Compared to this one is 2.9 for the lawn mover. For motorboard is 60. Average car is 148 horsepower. And for the maybe large car, I think is a sport card, race card, I'm not sure. 645 horsepower. And where do you think the human fit in this scale? I don't know. Maybe it's something that you need to search. Okay, that's all for this, and we're going to break in 4 minutes. Before we go there, do you have any question?